Okay. So actually, we calculated the actual flow rate of air through the orifice. So that is the air or rate of air, that is volume rate of air that is used by the engine. Okay. Now therefore what is the, this is the rate, that means per unit time or per unit second. So that is the volume of air that is used by the engine per unit second. So if we try to calculate the volumetric efficiency, then volumetric efficiency is equal to eta volume is equal to the actual flow rate of air divided by maximum possible flow rate of air. Okay. So actual flow rate of air we have just calculated, that is this one. Okay, maximum possible flow rate. How to calculate that? So you know that, so maximum possible flow rate of air that is connected to the volume, that is connected to the swept volume, that you can understand. So swept volume means the volume swept by the piston between TDC and BDC. So that is the maximum volume the engine can inhale, right? So that is swept volume, right? Swept volume is the maximum volume. So this is per cycle. In one cycle, the engine can inhale maximum, that is Vs, swept volume. But what is the volume flow rate or maximum possible volume flow rate per cycle, per cylinder, per say time, unit time? So what we have to do? This is the per cycle. Therefore, we have to multiply this with number of cycles per second. So in one cycle, this is. Now, if I multiply number of cycles per second, then I will get the total maximum possible volume flow rate per, that is per unit second, isn't it? So, what is the number of cycles per second? Number of cycles for 4 stroke, number of cycles per minute is n by 2. N is RPM. So 2 rotation means 1 cycle. So n rotation means n by 2 cycles per minute. So what is per second? Therefore it is per minute. What is the number per second? Divided by 60. Divided by 60. Per unit time it is more. Per unit second it is divided by 60. So it is 1 by 60. So it will be basically, therefore it is Vs divided by, I'm sorry, Vs into N divided by 120 per unit time, per unit time. Okay. So volumetric, what is the volumetric efficiency? Therefore volumetric efficiency, eta volume is equal to actual, that is Q actual divided by theoretical, there is maximum. So what is that? Vs into N by 120. So what is QS? Q actual, Q theoretical multiplied by CD, discharge coefficient, right? That you have already calculated. So I am not going into that. That part we have already calculated. So that is called the volumetric efficiency. So that is called the volumetric efficiency, and that is therefore the capacity of inhaling air, right? So what is the capacity of the engine that with which it is inhaling air or basically sucking air or breathing air, right? So compared to the maximum possible capacity. Okay, that is the volumetric efficiency. So you can understand that what reading we are basically observing here, the RPM, the then what W, that is the load, the balance in the that is load in the spring balance, observed in the spring balance, then what else? RPM, then load, then delta H, that is the manometric depression, then what? This is related to what? Can you understand? This is related to power, or say all other quantities related to power. This is also related to power. This is related to air flow rate. This is related to air flow rate. And another thing is that is related to volume flow rate of fuel. So that is VF. And time definitely by stopwatch. So from that we will get volume flow rate, and multiplying the volume flow rate with density we will get the mass flow rate, and that mass flow rate will be used in say volumetric, that is thermal efficiency, brake thermal efficiency, or brake specific fuel consumption, then air fuel ratio, etc. Okay, so is it clear? So any question regarding that? I tried to discuss in detail. Okay, this actually have many calculations, so that is why it takes time. So if you have any questions, you can ask. No questions? All questions resolved? Okay, I guess. So we can stop. Thank you.